But anyway, but what if this information is not enough to figure out what the issue is? Well, in that case, there is a way to create a memory dump for a kernel. It's called kdump. So what is kdump? Kdump is a particular case of doing Kexec. When you boot your system, a memory region has been reserved, and a copy of your kernel and initRD is being loaded to the area. And a special hook has been registered. And if your kernel crashes, a jump to the second kernel has been performed, and your new kernel boots. It has a special tool and script in its initRD, and when it boots, it dumps all your memory to a file and reboots. So you have a memory dump to analyze. So it's great, it works, but, well, there is an issue. It doesn't work for Zen. Why doesn't it work for PVHVM guests, which look like real systems? Well, mainly because of these two letters in front, like P and V. This guest is aware of the fact that it is running on Zen, and it uses paravirtual interfaces. And these interfaces are not ready to be reused by another kernel, and there is no way to reset them or do something to them. So which interfaces I'm talking about? So we have shared info page, which has been mostly used for events, and it's been mapped. We have vCPU info for data structure for each vCPU, which is also mainly been used for events. We have these event channels and their internal state in Zen hypervisor, and we have grant pages. So about the shared info page. So it is a single page, and it's, as I said, it's mostly been used for events. And upon boot, guest, at least Linux guest, it does the following. It selects a random page and it issues a special hypercall and asking Zen to replace this page with a shared info page, which has been allocated for a domain when it's been created. So this page, which has been sacrificed, is being freed by Zen, and this shared info page is being mapped. So what happens when we try to boot second kernel? Well, this second kernel can ask to map this shared info page to some other address, but we will get a hole. And if we access this hole, we'll most probably crash. We have event channels, which are being used for event delivery for guests. And when guest boots, it binds event channels to like virtual IRQs, physical IRQs. And what happens when we try to boot our second kernel? Well, we can't bind this twice, so we get an error, something like that. And there are also some event channels which are not being set up by the domain itself. They are being set up by the tool stack when the domain is created. These are mainly inter-domain channels. And if we actually have one big hammer to reset everything in Zen, but in case we use it, we lose these channels, and there is no way we can reestablish them. So grant pages. Grant pages is a memory shared a mechanism for memory sharing in Zen, and it's been used mostly for front-end, back-end communication for paravirtual drivers. And well, we have a single page which belongs to our domain, but at the same time it's been mapped to the other domain, to the hardware domain. We can't do anything with that because, well, there is no hypercall to forcibly unmap them, and we can't replace them because we don't have additional memory. And if we start a new kernel and we somehow access this page, which has also been mapped to the other domain, we will most probably crash because this other domain can also modify the page. And we are not aware of the fact that we can touch this page anymore. So it's maybe not an issue for kdump, because for kdump we have a separate memory space, and there are no grant pages there. But for general Kexec case, if we are interested in supporting such, it is an issue. We can transfer the knowledge from old kernel to the new kernel about these special pages. And moreover, we need these backends to work, because, for example, we need a hard drive to store our memory image. And if it doesn't work, such kdump or Kexec won't make any sense. So how can we solve all these issues? Well, I actually started working on this like a year ago, and my first idea was kind of do an obvious thing. Well, if there is an interface and there is a hypercall to set something up, well, let's introduce a hypercall to tear things down and return to the original state. So we'll reset like vCPU info. We'll do something with event channels, like mainly switch to this original two-level ABI. We need to somehow unmap shared info and replace it with a normal page. And we need to do something with granted pages. Not sure what. And it looked good, like, oh, let's think about it from a hypervisor perspective. We have a guest, and there is a hypercall to do some stuff. Well, there should probably be one to revert it back. Then we can, for example, test the hypervisor that, I don't know, it's not leaking memory by doing it like 100,000 times. Well, it didn't work out. Mainly because all these interfaces are kind of dependent one on another. And to tear things down, our domain will have to follow a specific protocol. And it's not going to be easy because, well, such paths with error handling and everything, it won't be like super simple. And when our kernel crashed and we are in this kdump mode, we don't want to do anything. We just want to like run as less as possible. We also don't know what can be done with granted pages. There was an idea that for any page we want to grant, we need to reserve one and use it if we want to replace it. But that looks a bit insane. And as I already said, that there are some bits which are not being set up by the domain, and if we use a hammer like reset everything for event channels, there is no way back. So a new solution was suggested, like, what do we need to do this Kexec kdump? We only need our domain's memory, actually. So instead of trying to tear things down, let's just create a new domain and reassign all our memory to this domain. And, well, this approach has its own benefits. Like, we don't need to take care of all the things. We just need to create a new domain. We can reuse migration. Actually, we'll be like self-migrating. So we'll be just transferring memory pages from one domain to the other on the same host. And it's also good from supportability, because if in future we introduce some new bits in Zen, we don't need to tear them down. We just create a new domain, and it's clean by definition. So, turned out, it's not that simple. We have these memory pages, and we have all other things around. For example, we have populate on demand. Populate on demand means that in P2M table, it's written that there is no real page which is been allocated for this address, and if someone tries to access it, a page will be added to the domain. And so we need to not only reassign actual memory pages, but we also need to walk through all these P2M tables and copy all these marks. there was an issue with mem access because, well, if there is an external tool which watches some events from some pages, what do we do on this pages reassignment? Do we copy all these mem access attributes or do we clean them? Isn't it a threat from security perspective? The idea of reassigning a page when it's been freed didn't work out well for ARM, because on ARM there is no M2P table. And to look up an address, we need to do a full walk. And if we happen to have many pages for a domain, it will take us a while. So hypervisor maintainer didn't really like the approach. And the last and the solution which is going to probably work out, they suggested was, let's return to the original idea of resetting everything. But instead of doing all these hypercalls to reset this, reset that from our guest domain, let's somehow collaborate with the hardware domain, and let's just ask our hardware domain to perform a special hypercall which will clean all things at once and reestablish all things which it established upon domain creation. So a new hypercall was introduced, and it does all the stuff at once. So shared info, vCPU info event channels, everything has been reset at once. Tool stack will restart the QEMU process because, well, QEMU also sets some things up upon startup, so we need to restart it to make our life easier. And, well, until now, everyone likes such approach. So there is a question what do we do with grant pages? Because, as I previously said, there is no good way we can unmap them. And the idea now is let's do nothing with them. What happens when we destroy a domain? Well, backends are supposed to register then special watches on then store. And when our domain dies, they're supposed to unmap all granted pages. Otherwise, they can't be freed until they're mapped. And our domain will remain in a zombie state. And as we know that they usually do that, let's reuse this. And so let's just remove our domain from then store. All backends which are good backends are supposed to release all their mappings. And then we introduce our domain back, and everyone who is interested in watching for the domain creation will receive a signal that a new domain was created, and, well, they will start from scratch. Well, there is a special debug info to track things down, track these misbehaving backends, if there are such. And I know for at least one backend which doesn't release its mapping when we remove a domain from then store. It's then console D. It works like that. It periodically scans all the domains, get the list of all domains we have. And if there is someone missing, it assumes that this domain died. And then it releases its mapping for its granted page. And, well, they're not destroying the domain, so this one page remains mapped. So, isn't it a problem? It isn't. Why? Because it's the same as when our domain starts. Because this page is being mapped before we actually start our domain. And it's been done by the tool stack. And our guest domain is aware of this special page. So in early boot, it will know that this particular page is special. It won't use it. And it's how it behaves nowadays on its first boot. So our Kexec kernel will do the same. So what's the current status? Well, unfortunately, this solution missed the 4.6 release, which is going to happen like in 1 month and something. My V10 series is on Zendevel list, and it's mostly been acted and reviewed. It's actually, all patches were reviewed, and only one of them is missing an egg. So if you are a toolstack maintainer, go and look at the last one. Yeah, this series will also need testers, because as far as I'm concerned, I'm the only one testing it right now. And there are probably some configurations which won't work, because, well, now we have an explicit list of things we reset. If in case we are missing something, we'll have to find it. And so testing is always good. Yeah, I also promised to tell something about PVH, but recently there was a development here, and we're going to be rebranding PVH, and it's only going to be like an HVM without device model. And in such case, I haven't tried, but it should just work, because, well, it's not going to be any different from an HVM domain. And the only thing which differs is we don't need to restart the device model. We don't need even to start it. So it should just work. We'll see when these patches for PVH land. I'll try testing it. This approach can also work for ARM. And for now, in my patch series, it's -NOCs, and it's not going to work. I haven't tried that, but just by code inspection, I can tell that we probably need to do the same thing we do with the shared info page, which we reset. This code is almost the same for both ARM and x86. So we'll have to unmap it and replace it with a new page. And then our Kexec kernel can map it again. And probably we need some this interrupt controller cleanup, because we do some setup. I'm not actually sure. I encourage everyone to try it with ARM. As far as I know, Kexec for ARM works. So I mean on bare hardware. So I don't really know why it shouldn't for Zen guests. So thank you very much. Questions?
One hesitates to suggest, why do you need this? Why don't you just take a snapshot of the Bolton VM and get your memory dump from it?
Well, imagine there is a cloud environment, and you run your VM somewhere. So to get a snapshot, you need to ask your cloud provider or someone, and you usually don't have access to that. Imagine you're running an Amazon VM. How would you get that? No, Amazon can take a snapshot of a VM, for sure. And there is Zen, dump, core, something. You can use it and you can get the same crash. It's easy, but it's not accessible to the user of the VM. It's only accessible to the user of the host.
Fundamentally, when you've got your host admin as a separate entity to your guest admin, you don't necessarily have the ability to pull. Yeah, if I am the host admin and the guest admin, I can.
Yeah. So in that case, it works for Zen. And
Why don't you use the strengths of VMs?
well, it could be done in a completely different way. So we could have introduced some, I don't know, a way to transfer, a way for a domain to ask the hardware domain to create a full dump of it and transfer it back, because where would it put it, the host? You have this image, where would you put it? On your own file system. You don't usually have it. So just separation of this host and guest administration. Yeah.
I think you mentioned a new hypervisor call, so that probably requires changes to the send host as well to support that hypervisor call. You
I'm
said,
not.
like, I need a new hypervisor call to.
Yes,
ask
yes,
for
yes,
features
yes,
of
yes.
device.
Yeah, if you look at my patch series in page 0, it's written that you need a one-liner change to a Linux kernel to issue this hypercall upon Kexec.
And this send hypervisor needs to handle that. So is it already
Yes, it's just like a shutdown hypercall with a special reason, like reason shutdown soft reset. This reason is being sent to the tool stack, like, oh, our domain is trying to shut down with soft reset reason, and then tool stack is supposed to issue this reset everything hypercall. You can actually tune it because in the domain config you'll have a new variable like on soft reset. What do? You soft reset or just destroy it, for example. It's going to be tunable.
But yes, this does require more a new hypervisor and a new tool stack. Because at the
Yeah.
moment, the hypervisor will limit check on Macs and say, oh, that looks a little bit large.
Right.
So the way we do this in the Citrix Windows PV drivers, which are also available for Zen Project PV drivers, the way they do this is they specially reserve a couple of grant entries and a couple of event channel entries that are explicitly reserved for use of the crash kernel in Windows, at which point it can reconnect the back-end rings. So this works without any tool stack interaction and might be a plausible stopgap mechanism if you want to do something like this on an unmodified system.
Yeah.
So in your slide, you mentioned that you reset everything in your file solution, right?
Yeah, yeah.
So but if we are using the kdump, so if we reset everything, then kdump is not able to read the crash dump content.
Yeah, yeah. Everything except for, actually, what we need is we need the domain's memory and like CPU context to continue executing it. We don't actually need the CPU context, but it won't work without it. So reset everything, it means like everything we need, not everything.
Okay.
So we have the same domain, and we just like reset event channels, unmap shared info, vCPU info, all these paravirtual interfaces which prevent us from starting from scratch, not the domain's memory.
Okay.
It remains intact.
Okay, thank you.
Thank you.